Standardized tests love talking about even and odd numbers because they have some basic patterns in them that's useful if you know it, but it's also something that you could just rediscover on your own if you needed to during the test, so you could kind of work through it by logic. So one thing that you may know coming into this is that an even number plus an even number is always equal to another even number. And likewise for odd numbers. In other words, an odd number plus an odd number is always equal to an even number. The only way to get an odd number by adding two things together is by adding an odd and an even. Go ahead and test this out if you want. Pick a few numbers, try it out. You'll see it's always true. So we're saying we've got some scenario here where you have integers n and m. Okay, they're going to be even or odd, I don't know, such that n minus m is odd. Which of the following statements must be true? Well, there's nothing special about addition. In fact, since even numbers can also be negative, you can imagine, for the purpose of this problem, that these are minus signs. It'll still be a true statement. So, if the result is odd, that means we're looking for the case where one of these things is odd, one of them is even. M is odd? Well, yes, maybe that's true, but it's not necessarily true. What if m is odd and n is also odd? Then the statement must be false. And remember, I'm looking for something that must be true. What about n is even and m is odd? Well, that would work. That's a maybe. The reason I'm not going to say it's definitely absolutely true, I knew m is odd is not necessarily true. N is even, m is odd. Well, let's give you a counterexample. Let's say n is odd, okay, n equals 5, and m equals 1. Oops, hold on. N equals odd, m equals even. There we go. Okay, n equals odd, m equals even. This is not what the example says. The example said the opposite. And yet, if I do n minus m, look what I get. N minus m equals 3. So this statement is very sneaky in that, yes, that would produce an odd result, but it's not necessarily true that n is even, m is odd. It could be the other way around. It could be n odd, m even. That's the sort of thing you have to watch out for here. So let's take another one of these in turn, right? This doesn't have to be true. N squared minus m squared. Does that have to be even? Well, I don't know. Let's try it out. If n is odd, let's say odd squared minus even squared. What is that going to be? Well, the neat thing about even numbers is if you square them, you get another even. And the interesting thing about odd numbers is if you square them, you get another odd. Odd minus even, that must be odd. So this statement is false. And let's see about the next one, n squared plus m squared. Well, that's the same as just changing these to plus signs. And that is true. This must be true, in fact. This is always going to be true. And you can play around with n and m as different integers. I encourage you to do that, actually. You'll see it's always true in this case. And this next one does not need to be true, right? It's not necessary that n is greater than m. It could be the other way around. It could be m greater than n. So there's only one statement in here that is always true, and it's this one. The tricky part about this problem is many of those other statements might be true or might be false. So in terms of the theory, I would remember this one. This is the important thing, okay? And that could be a plus or a minus. Another important thing in terms of the theory is this idea I talked about right here. Odd squared is odd and even squared is even. Those two ideas will help you get through this, but if all else fails, just guess numbers and find examples where one of these statements is not always true.